Ji, Bismillah Rahman Rahim. Today we will start our discussion on the research methodology. This is our third lecture, and we will discuss about research process. And on this slide, you can see that how that process flows, and you can also observe that there are feedback and feed forward mechanism in this flow process. So on some places we might go back to the previous step, and similarly in some situations we will feed forward to the other component of this research process. So we start with the definition of the research problem. That is the first thing which we have to do, and uh, that is one of the very important tasks while we are undergoing any research. You have to come out and to define explicitly your problem statement, what actually you want to do in that particular research. And once that research problem or a problem statement is clearly identified or clearly defined, then you have the two tasks which are in parallel. And the two tasks which you normally do is number one is review concepts and theories, and the second task is review previous research findings. And basically, these two tasks are basically comes under the literature review. And for any kind of research, the literature review component is very essential. So while you make any hypothesis or problem statement or research questions, it is very important to know that whether you have gone through with all the relevant theories, principles, fundamentals, along with all the research which basically is related to the topic which you have identified. So we have to go through with the fundamental concepts and theories, and obviously we'll go through with the review process, research design findings. For example, if you opted for, let's suppose, for the application of fuzzy logic in identifying any relationship among various images which are being obtained from various sources. So now you have to go through with all those algorithms which are already there. You have to study the fundamental concepts about fuzzy logic theory, and then you have to see that how various researchers have applied that fuzzy logic into this particular problem. Similarly, if you opt for a research, let's suppose in the domain of a network science, and you want to see the application of, let's suppose, the COVID-19 spread out in the form of network analysis. So there you have to comprehend all those related concepts. For example, the concepts related to network science, the fundamentals, the graph theory, and similarly, then you have to also review all those papers which are relevant to the topic where you have seen some sort of application of network science in that particular domain. And once that review is done, then you are in a position to formulate the hypothesis. That is actually the main thing, and you can say the problem statement, or you can say the hypothesis means that what you want to actually prove in that particular research, how you relate various variables together in the study, how you understand that concept, and you write that hypothesis. And actually you will see that in the rest of your research work you will try to prove that the hypothesis which is listed. So sometimes we formulate the hypothesis, or sometimes we also formulate the research questions based on the research objectives. So that basically depends upon the type of research which you want to do. But moving towards the fourth step, and that is your design. So that is design research, that is includes the sample design, and which is followed by the next step that is called collect data, and similarly the third one that is called the analyze data. So you have to design a research. For example, if you have formulated a hypothesis, then you have to either you have to design an experiment, that how you actually go through with the experiment, what are the steps which are being involved in that particular experiment, what type of actually research you want to do, how you will collect the data. Either you are only concentrating on the secondary source of data, or there is any mechanism which you have identified in the design research that you will collect the data or the primary data from the sources which you identify in your research design. These components are very important components of research methodology. Whenever you conduct any research or you want to do your MPhil or a PhD thesis, you are very careful about your research methodology or research design, because lot of concentration is being made by the reviewers to see that how you have actually conducted your research. So that design research might include that what methods you will use. That design research also include for example, the identification whether you go for the quantitative empirical one, or you want to go for the qualitative data. After the of course, in this process we have to feed forward, we have to use the feed forward mechanism, because we have to formulate the strategy for the collection of the data. For example, your research basically, if your research is based on, let's suppose, body sensor networks or sensor technology, so there you have to identify what type of sensors you will use in your research. And obviously, whatever the sensors which you are using in that particular research have to be standard ones and normally used in such scenarios. And whatever the data you want to collect from those sensors is to be accepted. So once you have designed the problem, that how you will use those sensors, where those sensors will be deployed, and how the readings will be taken, how the data will be transformed from or collected from the sensors to your device. Let's suppose you want to have a mobile application for the connection medium. So all that defined in a research problem or a design research. For example, if you want to uh, do research in database concepts or databases or optimization, query optimization, or other related concepts. So there you have to define the problem, what type of data you are actually considering. If you want to have any new design or change in the conventional models, how you will do that. Let's suppose if you want to introduce some new concepts of layers, or you want to apply some sort of hybrid methodology where previous models have not done that, and you believe in your own problem statement or hypothesis that this works well in the given situation. So you have to come out with in your research design. So the collection of data is very important aspect, because in any research, especially if you are more focused toward empirical research or otherwise as well, you have to collect the data. You have to have some sort of sources. For example, If you are dealing with, let's suppose, image analysis problem, then or image processing problem where the images are involved, then you have to see that how those images can be collected, what quality of images can be collected, how those images are useful in your own problem. Okay, what is the primary source for collecting that images? Let's suppose if you are doing this problem in a medical domain, there for instance, you may opt for the MRI images or or specified image format in medical science, that those are called DICOM images. So there, whenever you go for that research, you have to go for DICOM images. But let's suppose if you are doing the same research in any other domain where you are applying the image analysis, or let's suppose in any AI problem you are using those images, there you might not need DICOM, because DICOM is not the standard for other kind of problems. But in a medical science, it is a kind of standard. So similarly, if you want to collect data about, let's suppose, in any given environment, you want to your research problem, if it is based on the medical domain, so you have to collect all that medical data other than that images. So there you need to have that data about patients, and obviously that data regarding their, maybe their vital signs or all those characteristics which are being defined in the test reports, and which are relevant to your problem formulation. Let's suppose you want to do a research and try to find out the relationship of the diabetes, type 2 diabetes, in the COVID-19, with the COVID-19. So you want to collect that data and you want to analyze it and you want to prove it whether it is the case or not. So analysis is another important concept. So you see that in the collection data, you can see and after that collection data, you have the analyzed data. There you will find F. So it means that if there is anything goes wrong with the analysis, you have to see your collection data collection mechanism. What is your data collection mechanism? Let's suppose your data might not be in the correct format, or your data might not in good in number, because whenever you are looking for the sample data, it is very important that according to the problem, you have to identify that what is the minimum sample you might have for that particular problem. Let's suppose if you are doing a PhD problem, and let's suppose you want to apply any machine learning algorithm, so you must know that how much, at least how much sample data is required to come out with any conclusion, because there you also need some data for validation and for testing as well. So when our analysis goes wrong, or the desired results, if you do not achieve the desired results, it means that there is something wrong with the collection of the data. So when you go about analysis, again you have to define that all those analysis procedures in the design research, because there you have already identified what type of analysis you will use. Either you will go for the statistical analysis or the descriptive statistical analysis, either you are dealing with the time series data, or you want to apply some sort of mathematical model, you derive some mathematical model, and then you want to execute this with the data you have, and to see that what type of results you will achieve to test your hypothesis. So analysis, maybe you apply the spatial analysis, or you want to have some sort of temporal analysis, or you want to have some sort of network analysis. So if you want to have a network analysis, then you might have different tools which are available. So there are various tools available for analysis, and even you can write your own code to execute it. So lots of options are there. Let's suppose people are using also the standard packages which are generally accepted in the research community, if you are using those packages as well. For example, if you want to analyze that data using R or R project, it is acceptable all over the world. Let's suppose you might use MATLAB as a tool for an analysis of data, because there are libraries which includes almost all the important uh, empirical tools related to the statistics, maths, and the related things. So analysis is important, and obviously after analysis we are in a position to test our hypothesis whether we are correct or we are wrong. For example, let's take an example that you have identified a problem that you will identify any bone deformation or a backbone deformation in any given patient, and for that purpose, you have interacted with the various domain experts and you look for the MRI images of the backbones. And after doing certain analysis or a machine learning algorithms, now you want to make the statement that how much deformation is being done. So obviously, you are considering some variables or some parameters of which you have identified after the discussions with various domain experts, because how they identify that bone deformation when they look into MRI images. So after the analysis, you understood that the error rate or a margin rate is a bit higher, on the higher side, compare to the statement we have actually with the machine which is generating that particular MRI. So it means that there is something wrong with your collection data, might be the collection data process. So there you need to feedback and to see that how that can be improved. You might need some more images so that your mechanism works well. And obviously, once it works well, then you are in a position to interpret it. So interpretation is a very important aspect of a research process, because lots of time we apply tools because applying tool is much easier, and sometimes we have no problem in applying any particular tool, but since we do not have a good knowledge of a particular tool or a concept, then we are in a position where we do not able to interpret it, or we're not able to conclude it. So it means that your review of literature and the review of the fundamental concepts is very weak. So normally whenever we go for that analysis, it is very important that we must be in a position to interpret the results. Now for that purpose, obviously we have to carry out that experiment many times to see that how that results are changing and how you interpret those results in terms of the problem you have. So definition of the research problem. So research problem refers to some difficulty oblique need which a researcher experiences in the context of either theoretical or a practical situation and wants to obtain a solution for the same. So it means whenever you identify a research problem, obviously you are referring to some particular area, some particular domain, and obviously you have identified some sort of research gap over there, and you have come out with the solution of that. So it means that you have a clear idea of that problem in a particular context, whether it's we talk about the theoretical situations, or either we talk about the working or a practical situation, and obviously you are looking for a solution. Let's suppose think about certain problems, let's suppose in the database systems you have identified that the existing query optimization algorithms won't work well in, let's suppose, the probabilistic databases. And then once you have identified the problem and the reason why it is not possible, then you come out with a new algorithm which works well in, let's suppose, in the context of probabilistic databases. So you have identified a certain problem. Obviously you have identified that problem from the literature review where you have that idea. Let's take other examples as well. Let's suppose there is a COVID-19 problem all over the world, and we are going through with various waves of COVID-19, and you have identified a problem that there are different spreading phenomena in the world. Somewhere that is the COVID-19 is spreading in a much faster rate compared to other countries, and you want to know that why the spreading from phenomena is different, for example, in Pakistan, in UK, or in US, or other countries. So you come out to model it, and then you want to make a prototype, and you want to make an execution and want to see that how actually this happens, or you want to simulate it. So again, your problem is a different kind of a problem. Let's assume you come out with a problem where you want to use a machine learning algorithm to identify that, let's suppose, the given person is either guilty or not. So you identify, it means now you have a different sort of a problem. You want to have various images of the individual, and then you try to determine that whether that individual is the culprit or not. Similarly, you can think about a problem of a security, and you identify that in a given types of a network there is a security concern, and for that particular security, the present or the available research available security algorithms are not fulfilling the criteria, and you come out with a new approach which was not there. So again, that is your research problem. You exactly know that what you want to do and how you want to apply it. So think of lots of problems in the computer science domain. You might be interested in software engineering. You might be interested in pure computing side. You might be interested in more towards the development side, or the let's suppose you might be interested in clouds, or in a distributed database application uh, such as blockchain, and how you want to apply that blockchain, let's suppose, to handle that COVID-19 situation, or the blockchain to handle to be applied in the medical domain, let's suppose. So you must have a clear idea of the problem. If you do not have a clear idea of the problem when you discuss with your supervisors, then please do not proceed with that further. Otherwise, you will get yourself into trouble. So it means you must have a clear understanding of the problem. So, so there are various ways by which we can know that what type of problems you might have. For example, with the help of the complaints, let's suppose so many complaints we have about a certain system. So we want to identify what type of complaints are there, and we can identify the problem. For the various kind of behaviors, even by humans or machines, that is that refers more towards a company in a given situation, um, or deviation from the business plan, so on and so forth. So there are various ways by which you can identify the problem, um, and your observation does count. So if you have a good observation, then you can identify that what type of problems you are having, and how you come out with the solution. So every time, whenever we have a problem, we have a solution. So whenever we identify the problem, we think about solutions, and whenever we think about solutions, you might have more than one solution. So the first step in the research process is to define the problem. which involve two activities. Number one, identification oblique selection of the problem. That counts a lot. What type of research you are doing. Let's suppose if you are in your BS program and you are doing your final year research, then the scope of the problem is limited. If you are doing this research at the MPhil level, of course, the scope of the problem is bit widened. And similarly, if you are doing a PhD research, then again that counts a lot. So lots of topics we accept for the thesis in the BS level or bachelor level, we do not accept at the PhD level because of the scope of the problem. And second thing is how you formulate the problem. So the this step involves identification of a few problems and selection of one out of them after evaluating the alternatives against certain selection criteria. So how to identify a problem? So you have to identify, of course, and how you will come out with various alternatives. When you evaluate various alternatives, only then you might select a problem, and that is by reading, by your academic experience, daily experience, your exposures, consultations, brainstorming, your own working, previous working of research, and intuition. That is very important. So all these activities help you to identify the problem. The basic problem with all these students, research students, is that whenever we ask them, they generally enroll in MPhil and PhD programs, and then they say, okay, sir, we don't know, we do not have any idea, sir, what to do. This is a common problem we have, because whenever we ask them to come out with a problem, now then they are puzzled. They don't know how to come out with the problem. Although we are living in a society where we have lots of problems around us. So look for a problem, and for that purpose, your intention does count. Your mental alertness does count. How you observe things, how you believe that how you can solve that problem. Let's suppose by using information technology, or by using computer science, by using artificial intelligence, or by using the communication technologies. So that is very important that you discuss with others, you discuss in your groups. You have a good idea of, let's suppose you follow various magazines, or you follow the let's suppose the important research publications which are or the inventions which are there in that era. So, and you feel yourself that what type of problems you have. Let's suppose in Pakistan, if we are there in our society, we can also realize that lots of problems. We have problems. Let's suppose, okay, see the situation of a traffic. Okay, traffic is one problem. Okay, how we can use ICT to solve that problem, how we can make such a problem statement, and what type of solutions we can have for smooth trafficking. So think about that. Urban planning, okay, that is one more problem we have. Okay, think about that problem. Okay, that is the problem we have, how we can deal with that problem. Spreading of COVID-19, how we use ICT for that purpose, how we can have that data, how we can analyze that data, how we can make relationships among that data. So it is very important that you have to expose yourself. Research can never be done in a single room. If you lock yourself in a room, just have your laptop, and you think that you are a good researcher, you will identify the problem. No, you have to have in the field. You know exactly what are the problems, what are the areas. Let's suppose if you are good in software engineering, you might come out with some development methodology or a hybrid approach. Maybe you come out with some sort of forward engineering tools for the design, for example, for the development, or even in the area of quality assurance. So that is very important. These are all sources of examples. So with this slide, I just want to have your input.